Anybody else who has AirPods in, please take them out. All right, so the first thing I'm going to look at is the domain. Right, and when is our domain affected? Our domain is affected if there's a variable in the denominator, and also when else is our domain affected? Michael? Good, if there's a radical. So our domain's affected if there's a variable in the denominator or if there's a radical anywhere in the numerator and the denominator, it will affect our domain. So we're going to, obviously no radicals here, but we do have a variable in the denominator. So we're going to take that and see what happens when it's set equal to 0. So we know the value of x that will make this 0 will be when x is equal to plus or minus 1. So what does that mean? Our domain cannot equal plus or minus 1, because if our domain were positive 1 or negative 1, we would get 0 in the denominator, which makes it undefined. So what does this mean we're going to have at x equals 1 and at x equals negative 1? What are we going to have in our graph? You got it. We're going to have two vertical asymptotes. So we're going to have a VA, vertical asymptote, at x equals plus or minus 1. Right. Did we speak about holes in the graph? We did. We spoke about holes in the graph. When will there be a hole in the graph? When will there be a hole in the graph? Good. If something would make the denominator 0, but we end up canceling it out. Is that the scenario here? Will anything cancel out? No. Since nothing cancels out, there will be no holes. There will be no holes in this graph. All right, the next thing we want to talk about, so we have our vertical asymptote. The next part we want to talk about is a horizontal asymptote. And we find the horizontal asymptote when we take the limit as x approaches positive and negative infinity of our function. Well, because we're approaching infinity, don't we take the most influential on top over the most influential on the bottom? Now, our most influential on top is not x, because our numerator is this quantity squared. So when I take this quantity and square it, what's the highest exponent going to be? X squared. Is there any coefficient? Well, it's coefficient of 1, so no. So we're going to have x squared over x squared, which simplifies down to 1. So that means we will have a horizontal asymptote at y equals 1. So we have vertical asymptotes at x equals plus minus 1. We have a horizontal asymptote at y equals 1. The next thing we're going to ask ourselves, will it cross? Will our function cross this horizontal asymptote? And the way we figure that out is we take our function x minus 2 quantity squared over x squared minus 1 equals the horizontal asymptote 1. And then we try to solve for x. We're seeing, will it cross? So what I'm going to do is I'm going to cross multiply. So I get x minus 2 quantity squared equals x squared minus 1. I'm going to have to try to solve for x. In order to solve for x, I need to FOIL out that left side. I need to multiply it out. And when I multiply this out, we are going to get x squared minus 4x plus 4 equals x squared minus 1. What happens with the x squareds? They cancel. If I were to subtract x squared on both sides, they both end up canceling. So now I have a negative 4x plus 4 equals negative 1. I'm going to subtract that 4, so now I'm going to have negative 4x equals negative 5, so x is equal to 5/4.
That's not the 0?
This is not a 0. This is where we're crossing the horizontal asymptote. Can we ever cross a vertical asymptote? Never. But sometimes we can cross the horizontal asymptote. And in this scenario, we are crossing the horizontal asymptote. So let's write this up here. Does it cross HA? So yes, because we ended up getting an x value, it absolutely crosses HA at the point 5/4, comma, what was our corresponding y value here? 1. Now, in this scenario, because we're sketching, it might be easier to change this to a mixed number. So 5/4, isn't that 1 1/4, comma 1? Okay, so we had our horizontal asymptote. We asked, does it cross? Now let's find the zeros. How do we find the zeros? We don't take the denominator set equal to 0. The denominator set equal to 0 gives us our vertical asymptotes. The numerator set equal to 0 gives us our zeros. So we're going to take the quantity of x minus 2 squared and set it equal to 0. But think in the world of sketching. When we have this, isn't this an even exponent? Because it's an even exponent, is this a cross or is this a bounce? This is going to be a bounce. So where are we going to bounce? We're going to bounce at x minus 2 equals 0. So x will equal 2. So it's basically a double root. It counts twice. That's why we're bouncing. Okay, let's start getting a sketch going here. We have enough to get parts of it going at least. All right, so we're going to have a vertical asymptote at x equals plus or minus 1. So x equals 1, x equals negative 1. How do we represent vertical asymptotes with what kind of line? I think I heard it. Dashed, yeah, dashed line. So I'm going to have vertical asymptote here, vertical asymptote here, and then we're going to have a horizontal asymptote at y equals 1. And there's our horizontal asymptote. Right, now let's plot our zeros, which is just going to be x equals 2. Here's a 0 here. And then there's one more point to plot that we have listed right now. We have that we are crossing our horizontal asymptote, and we're going to cross the horizontal asymptote at the point 1 1/4, comma 1. So this is not obviously exact. Here's 1, here's 2. 1 1/4 will be a little bit closer to 1, right? So we're going a little bit past 1 and then up to 1, and that's where we're going to cross our horizontal asymptote. Somewhere here. So I can pretty much figure out what's going on this right side. How do I know I can pretty much figure out what's going on this right side? Because here's an asymptote, and we know this is a bounce, right? So what's happening is I'm going to hug this, but then I'm going to cross it, right? I'm going to hug it, but then I'm going to cross the horizontal asymptote. But then I'm going to hit that 0, but this was a bounce, right? So then what happens? I have to bounce back up and now follow the horizontal asymptote. Now, let's say you didn't know. Let's say you couldn't figure that out. What should you have done? We should have plugged in points. So I would think this top part would be pretty apparent that we can't cross this vertical asymptote, so you knew you had to hug it, you knew you had to cross it, and then you knew you had to bounce back up. But then what you can do after that is choose like 3. Plug in 3 and see, look, you're not crossing this again. We only crossed it once right there, so we can't cross it again. That was the only point we were crossing it. Okay, so now we still have 2 more sections to try to figure out. We have between here, right, between the 2 vertical asymptotes, and then to the left of the vertical asymptote. So what should we do? What I'm going to do now is just sort of pick points. I'm going to first go to the left of the vertical asymptote. So we have a vertical asymptote at -1. What can I use? I can use -2 and see what's happening. So now we have, so these are extra points we're figuring out. So I'm going to take x and I'm going to take -2 for x, and we have y is equal to x minus 2 squared over x squared minus 1. So we're going to have -2 minus 2 squared over 4 minus 1. So we're going to have -4 squared, which is 16, over 3. If we're going to estimate this, isn't this going to be 5 point something something, right? It's past 5, just a little past +5. So what does that mean? That means we are at -2. Oh, I only went up to 3. Let's keep going. All right, so I'm going extend my asymptotes here. All right, so I'm going past 5 a little bit, and I'm at -2. So what does this tell us? This is all I really needed. All I needed was that 1 point, which tells me I'm in this quadrant right here. Right, so I'm going to hug my vertical asymptote. I'm going to hug my horizontal asymptote. Am I passing my horizontal asymptote again? No, we only passed it that 1 time. Everything else, everywhere else, we follow the rules. Everywhere else, we follow the rules. So now we're going to go and hug it. So it looks something like that. All right, so now we have to figure out what's going on here, right, in between. So I'm between -1 and +1. Can I choose 0? Yeah, let's choose 0 and see what's going on between the 2 vertical asymptotes. So now we're going to have y is equal to 0 minus 2 squared over 0 minus 1. So we're going to have 4 over -1, which gives us -4. So now I have the point 0, -4, which is right over here. Okay. So I know I have to come from the bottom up and then go down. The reason I know that is because I have a horizontal asymptote up here at y equals 1. So if I was coming from up top, wouldn't it then pass the horizontal asymptote again? And we can't pass that horizontal asymptote. We only crossed it 1 time. We can't cross it again. So I know it sort of has to be like a frowning parabola down here. But let's say you didn't know that. Let's say you couldn't rationalize your way through that. Could you have figured it out by doing, let's say, -1/2 and +1/2? Yeah, you could have. You could have plugged more points in it. It would be more work, but you could have to see that you're in this area right over here. So So this looks something like that. And there's our graph. All right, let's get on to today's lesson. So if you guys remember in the first day, which I know it was a long time ago because we had the long weekend, we talked about vertical asymptotes, we talked about horizontal asymptotes, and then I wrote something else and I said not yet. Do you remember what it was called? Yeah, I said slant asymptotes, but not today. Well, today is slant asymptotes. So last class it wasn't, today it is. Okay, slant asymptotes occur when the degree of the denominator is less than the degree of the numerator. Or if you flip-flopped it, the degree of the numerator is greater than the degree of the denominator. Same thing. So you could either look at it as the degree of the denominator is less and the degree of the numerator is bigger, or the degree of the numerator is bigger, degree of the denominator is less than. Doesn't matter, both the same. Okay, we will not have a slant asymptote and horizontal asymptote in one graph. So it's will not have slant and horizontal in the same graph. So that means if you have a horizontal, you will not have a slant. If you do not have a slant, you will not have a horizontal. Sorry, if you do have a slant, you will not have a horizontal. Okay, so let's just jump right in and sketch a problem. So I want us to sketch y equals x squared plus 1 over x. All right, domain. Our domain is restricted in two scenarios, when there's a variable in the denominator and when there's a radical in the problem. Is there a restricted domain here? Absolutely. Why is there a restricted domain? Because there's a variable in the denominator. Can I cancel out that variable in the denominator? Can I cancel out the x here? No. Since I cannot cancel out the x, will there be a hole here? No. No hole since I can't cancel it out. What will there be? An asymptote. So we know our domain is that x cannot equal 0. We know that we will have a vertical asymptote at x equals 0. Perry? Okay, so we talked about the vertical asymptote. Let's see if there's a horizontal asymptote. So now we have we're going to check the horizontal asymptote by taking the limit as x approaches plus or minus infinity of x squared plus 1 over x. So since it's the limit to infinity, we're going to take the most influential on top over the most influential on the bottom. Now we will simplify this. X squared over x simplifies down to x. If I plug in the infinity here, we have plus or minus infinity. Is there a limit there? No, we're going to plus or minus infinity. So there really is no horizontal asymptote. No HA. Because we're approaching plus or minus infinity, there is no horizontal asymptote. All right, if we did have a horizontal asymptote, would we need to check for a slant asymptote? No, we would not need to check for a slant asymptote. But because there is no horizontal asymptote, we do need to check for a slant asymptote. So now for the slant asymptote, which I call SA, slant asymptote, this will occur if the degree of the numerator is greater than the degree of the denominator. So go back to our function. Is the degree of the numerator greater than the degree of the denominator? Yes, we have x to the second is greater than x. So therefore, there will be a slant asymptote. So now how do we find the slant asymptote? What we're going to do is we're going to use long division. To find the equation of the slant asymptote. So now we're going to take our function, which was y equals x squared plus 1 over x, and we're actually going to divide. So we're going to say x as our, on our outside, x squared plus 0x plus 1 on the inside. All right, well, x times what gives us x squared? X times x. So x times x is x squared. We then subtract. We bring down a 0. Well, obviously, x times what will give us 0? 0. Do I even need to put that? No. So then we'd have 0x, bring down the 1. What is the 1 considered? This is the remainder. I want us to ignore remainder. So when we divide, all we care about is the quotient. We do not care about the remainder. So now our equation is going to be equation of asymptote of slant asymptote will be y equals whatever the quotient was. What was the quotient? X. Y equals x. Can I ever cross a vertical asymptote? Never. Can I cross a horizontal asymptote? Sure. Can I cross a slant asymptote? Sure, maybe. Doesn't mean you always cross it, but sometimes you can cross it. The only one you can never cross is the vertical asymptote. So now I'm going to ask, does it cross? So what we do is set function equal to slant asymptote. So now remember, our function was x squared plus 1 over x equal to our slant asymptote, which is just x. Cross multiply, we get x squared equals x squared plus 1. The x squareds cancel. So then we end up with 0 equaling 1. Is that a true statement? No. So does it cross? No, it does not cross our slant asymptote. Okay, now, are we okay? Do you have a question? You're okay? You're okay? Okay, so now there was another part that we had talked about last class that never worked out. It was symmetry. So to see if there's any symmetry, what we're going to do is we're going to take f of negative x. So remember, our function was y equals x squared plus 1 over x. So now we're going to have negative x squared plus 1 over negative x. Well, this ends up becoming x squared plus 1 over negative x. Do we agree this is the same as saying the negation of x squared plus 1 over x? Just pull out that negative 1. Yeah, so what have we gotten? We've now got f of negative x is equal to the negation of f of x. So if you look back in your notes, that was a reflection over the origin. Or symmetry over the origin. Yes? Oh, in the back first.
So why did the negative apply to the 1?
It did. Oh, no, just the x's, because you're only plugging in negative x.
So it's only if the x's change? That's
Only the x's change, not everything, only the x's.
If it's negative x squared, how come it doesn't turn into just x?
Negative x squared, so that's a negative x times negative x, right? So when you do negative x squared is a negative x times another negative x. Negative 1 times negative 1 is a positive 1, right? But x times x is x squared.
Oh.
Right? This is x to the first times x to the first is x to the second.
Thank you.
You're welcome. Okay, was there anything else I needed? No, let's start sketching. Oh wait, did we do zeros yet? No, we did not do zeros. All right, let's do zeros. So for zeros, I'm going to take my numerator and set it equal to 0. So we get x squared equals negative 1. What does this tell us? Plus minus I, right? They're imaginary. So if our zeros are imaginary, what does that mean? Will I be crossing the x-axis at all? No, not in my graph. I will not be crossing the x-axis in my graph. Alrighty, let's do this. Get our sketch out. All right, so we have our vertical asymptote at x equals 0. So I'm just using a different color to really emphasize this. So we have our vertical asymptote there. And then I'm going to have a slant asymptote at the equation of y equals x. Well, this is a line. This is y equals mx plus b. So my slope is 1. What's my y-intercept? 0. So what is this telling us to do? Obviously, this is another asymptote, so it's okay that it's crossing that asymptote, right? Because these are lines we're not crossing in our diagram, in our graph. So then we're going to go, my slope is 1 over 1, so that means up 1, right 1. Up 1, right 1. Up 1, right 1. And then down 1, left 1. Down 1, left 1. Down 1, left 1. And again, another dashed line for our asymptote. Okay, so there's no zeros, there's no holes, we're not crossing any of the asymptotes. So now we have to figure out where we're going to be. So what I'm going to do is I'm going to pick a point to the right of my vertical asymptote, or an x coordinate to the right and an x coordinate to the left. So since our vertical asymptote is x equals 0, I'm going to choose -1 and +1 and see where we end up. So now I'm going to test those points. And I will choose +1 first. So y will equal 1 squared plus 1 over 1. So this is going to be 2. So that means we're going to have the point 1, 2. So what does this tell us right now? It tells me that I'm in this area right in here, right between my two asymptotes. So what am I going to do? Hug my vertical one, loop it around, hug my slant one. Something like that. And these are just sketches. They're never going to be completely accurate, but just an idea of what's going on in that area. Now remember, we said we were going to be symmetric through the origin. What does that mean? It means if I were to fold my paper over that origin, wouldn't I then create another same little loop over here, right? So you can just do that, just knowing it's going to be symmetric, or you can say, okay, well, let me just be certain. I'm now going to plug in -1 and see where I land. So if you plug in -1, you're going to have 1 plus 1 over -1, which is going to give us -2. So we are now -1, -2, which brings us exactly where we thought we would be. Something like that. Doesn't want to go straight. Something like that. Okay, you guys want to try one? This is the last problem for today because they're long. All right. So you guys try this one. So ask yourselves all the same questions that I've been asking. Domain, vertical asymptote, horizontal asymptote, slant asymptote, holes, zeros. Does it cross? All that same stuff. Sure. How are we on time? We probably won't finish this. Probably won't finish this. I'm going to stop recording this because I don't think we'll get through it.